to the cloud. Okay, welcome back everyone to the Shieldbot with Arduino distance learning, day 3. Before we get started, do any of you have any urgent questions that you want to ask or that have been on your mind, but
Andy, this is Andy.
Hello.
I just wanted to let you know that I have to drive 3 hours to go pick up something. So
oh my.
I'm going to try to follow along on a hotspot. We'll see how that works.
Okay.
But again, I can easily follow along in the book too.
Well, and the other thing is, you know, I'll be sending out the YouTube link. And so you can easily just fire that up when you get it. And one thing I like to do, let's talk about that for a second.
Yeah, I'll listen along while I'm driving to Iowa.
Oh, yeah. Wow.
Yeah, the most boring state ever.
Well, it's got some nice hills and dells around the Mississippi, but then it kind of flattens out as you go towards the other side. Let's see here. Need to bring up a YouTube video. Here we go. All right. So when you're playing back the YouTube video of any of the online learning sessions, one thing you can do is hit this gear right here and set the playback speed to 2x. And granted, it'll make my voice rather high and chirpy, but when you've got that nice playback speed, you can go through stuff a lot faster. And then, of course, slow it down when something comes up that is of interest. So that's a nice way to get caught up on what we're doing. Today is mostly actually going to be, now, does anybody see my video thumbnails, or is that only visible to me? So can you see the whole slide, or am I covering it up partially? You can see the whole slide. That's excellent. Okay. So, so today we'll do a quick review. Any last questions on the Whiskers navigation? After that, we'll move on to infrared troubleshooting, and then also look at some of the topics that are of interest there. And Andy, I do think that this will be worth watching at least at 2x speed over YouTube, because there's some interesting engineering topics both in infrared and in the light, the navigate by light.
Sounds good. Yeah, thanks.
Yeah, sure thing. And I hope to be sending that out tonight, really Monday at the latest. And so today is going to be much more informational. We'll do some troubleshooting on the infrared circuit and on the light circuit if needed. Let's see here. Then we'll take a curriculum tour, which is both Parallax curriculum as well as cyber.org curriculum. And we'll also talk about some additional things you can do that are not included in the book, some of which also require additional upgrade packages, kits, and etc. Okay, so with that said, here is the Shieldbot again, and just a reminder, we talked about which direction is forward for the Shieldbot and how it has a tail wheel. We also talked about the fact that the wheels have to turn opposite directions for forward translation. Now, because of the fact that the wheels have to turn opposite directions, it's a little bit counterintuitive, but what you have to do is take some amount above 1500 for left wheel forward, and then take some amount below 1500 for right wheel forward. And then you reverse that for backwards, and then turning in place, they're the same value, either above or below 1500. Now, somebody commented on Wednesday that was still kind of difficult, kind of counterintuitive. And so what we did in chapter 4 was go through some ways to address that. And one of them was by simply writing functions and putting the code in there so that your main code can say stuff like forward for 2 seconds, turn left for 0.6 of a second, and so on and so forth. But we can go beyond that and even make a nice little function named maneuver. And with maneuver, you can give it a left speed and a right speed and a runtime. But what's really cool is that maneuver does the corrections so that you can use intuitive values for your wheel speeds. Like maneuver of 200, 200 means full speed left wheel, full speed right wheel, both of them forward for 2 seconds. And then now here, the left wheel is going backwards, the right wheel is going forward. So the left wheel is negative, so it's going backwards, right wheel positive, going forwards for 0.6 of a second, and so on and so forth. And so the idea is that this function that has 3 parameters, it accepts 3 arguments, does the lifting for you, and it makes the maneuver calls nice and intuitive. Now, after talking about arrays and music, the chapter 4 ends off with something where we make arrays of maneuvers and then a loop that repeatedly calls the maneuver function. And that loop goes through and it grabs each of these groups of maneuver values and plugs them in the right spot so that we still get our forward, rotate left, rotate right, backwards, and stop. Okay, any questions about that? All right, then we moved on to Whiskers, and with Whiskers, we used that same set of functions that we wrote to execute pre-made maneuvers in the previous chapter, but we called them in response to whether or not one of the digital reads returned a 0, meaning the whisker was pressed against the post. We also talked about, pardon me, we also talked about the distinction between a pin being programmed to function as an output where it actually supplies 5 volts or 0 volts to the circuit. In contrast, when a pin is an input and it's reading, it's actually invisible to the circuit. So no current flows into or out of this 220 ohm resistor. The circuit just does whatever it's going to do. And the digital read will basically tell you, hey, has the voltage gone above 2/3 of the way to 5 volts? Yes, okay, it's a 1. Or has the voltage gone below 2/3 of the way to 0 volts, or 1/3 above 0 volts, however you want to look at it? Well, if that's true, then it's a 0. And so, but again, the circuit just does whatever it does. And so the circuit is changed externally when we're reading, and the Arduino is programmed to detect that. Whereas the circuit doesn't typically change externally. If the Arduino is working as an output, what changes is what the Arduino connects the circuit to through its I/O pins. And then we talked about, well, we actually talked about kind of a quick preview of infrared and a quick preview of light sensing. And so with all that, I'd like to find out how your infrared is going as we get to this infrared troubleshooting tips slide. So how many of you had a little infrared robot that could roam around on the floor and avoid? Excellent. I'm getting some thumbs up. Way to go, you guys. That's fantastic. Well, please do jump in, because if any of you don't have your infrared navigation going, it would be really important to talk about that. One, so that the group can see, you know, common mistakes like that students will make. And two, to make sure that your infrared is going well. So one of the things, or, you know, my list when I'm working with teachers in these classes in person is, well, first of all, I should have put this on there. I go to the book and zoom way in on the wiring diagram. And a lot of the time we'll find that maybe these two resistors here are plugged into 8 and 9 instead of 9 and 10, because even though it looks nice and big and obvious on the screen, as you're probably aware, it's kind of small and hard to see as you're plugging the wires into those little sockets, right?
Could I ask a question on that really quick?
Yes.
So I had a heck of a time getting my left one to read properly and ended up switching mine to 7 and 8 because I could not get it to work with 10 and 9. And I was wondering if you had any insight with that.
I have a similar problem. I can't get my left one to work.
Okay. Ah, good. We have some troubleshooting.
So I guess the first thing, this might just be my lack of knowledge, so if this is stupid, you can laugh at me, but I'm using 11 and 10 for my wheels instead. Are those, they're the same number as, like, is that related or is that super left field and I'm just making crap up?
No. Your first guess about it being related is actually going to be the cause.
Okay.
So what you're saying is that you switch these servo ports over to 10 and 11, and then you modified your code so that you're controlling the servos through 10 and 11. Is that right?
Right, which then, yeah, as I say it out loud, that was really dumb. So thank you. Sorry.
No. Glad you asked. Again, you know, the thing is that this is really, I mean, in terms of the bigger picture, after you've had a certain amount of practice, maybe it's not that difficult of a circuit, but for students who have just gotten here and assuming that they've built other circuits throughout the book, this is definitely a level up from the rest of the circuits. It's a level up in complexity, and you can multiply each wire they have to plug in with an increased level of probability that they made a mistake on one of them, that they either got it in the wrong place, that they, you know, chose the wrong color bands on a resistor, that they got two of the resistors swapped. There's just so many things that can happen, and troubleshooting is an expected part of this application. And so is it Jess that was
Yeah.
okay, so Jess, so what you did was you moved these two resistors down to 7 and 8, and then it worked.
Correct.
Okay, congratulations. So now you have a Shieldbot that not only does it not twitch when you start it up because you moved the servos over, but you adjusted the pins that were doing the infrared detection and then had success getting it running. And now we know why, is simply because there was a conflict between the servo signal coming out of pin 10 and the program that was also trying to make this infrared LED blink on and off with pin 10.
So is that why we start with 13 and 12 for the servos? I apologize. I know you were talking about that a little bit yesterday or Wednesday and my audio was cutting out. So you can ignore that question if you already went over that. I'm so sorry.
Oh, I'd say the honest answer was that that we started with the hardware this way to have it be compatible with the original BOE Bobot, the basic stamp Bobot. And then somebody in the group, after the first lot had already been manufactured, said, hey, you know, it kind of twitches when you start it up. And that's because that Arduino has that LED and it toggles pin 13 when it boots. And we talked about it and said basically, okay, well, these have already gone out the door, quite a few. And so now we need to just make sure that everybody knows, hold up your robot until it twitches, then set it down and let it go and do its thing. So that's how that came about. And then of course, give everybody the alternate choice of using 11 and 10. And, now that you mention it, next time anybody asks me about this, I'm going to make sure to mention that you'll have to move around some other circuits. Okay, so there was a second person who had an issue. Was it the same issue?
Nope, but I think I just figured it out. The little receiver, yes?
Yeah.
Yes, I just needed to move it over one.
So yeah, and that's a really common thing. I always call it a bomb site error. If you think about it dropping into the socket, so basically it wasn't in the right set of sockets. Is that correct?
Yeah, it just needed to be moved over to the left one.
Okay.
But I got to tell you, this caused me a lot of pain today.
Yes. And
I was doing it forever. I kept doing things and nothing worked. And I checked every wire, but no, I didn't check that. I just looked at your diagram now and I was like, oh, I think it's over as one. So anyway.
You saw it just now? Well, I do have to say that really zooming this in on your computer screen can, that's something I definitely would tell everybody to try with their students.
Another thing too, you might want to do, which I had to do, was go from, because I don't like to use the computer for this stuff. I've been using the book.
Yeah.
So I went in and actually color coded my book because it's printed in black and white so that the wires didn't get all jacked off. Because I was over here yesterday. First, I got it to work fine. And then my dog jumped on it. And then it wasn't working fine. And so I had to troubleshoot what it was. And she had knocked some wires out and I had placed them all in the wrong area. And when I went back to look at everything, it looked fine. And then once I ended up finally wanting to throw it into the pool and light it on fire, I went, hold on a second. And that little jumping wire that went from the pins to back to the, I think it was the second pin over on the 5-volt thing was actually off.
Now, Mike, you're talking to a group of teachers here and you can't get away with this. My dog ate my homework stuff,
no,
right?
But my dog literally.
I know.
So what was funny was remember our conversation about that skirt, getting these things to chase each other around. It took a little bit. So I finally got it to happen. And I was finding that the way I had it taped on there was completely wrong. So it was like kind of down at an angle like this as opposed to being straight for where the
so it was the infrared was hitting the skirt and then reflecting kind of downward as opposed to back to the robot. The good find.
And I just got it right, and then the dog jumped on it. She's a bit of a spaz when I ignore her, so that happened.
Yeah, for us, our cats get jealous because I'm paying attention to this inanimate object that occasionally annoys them as it skirts around the floor. And so I've come back to find our cat chewing on the robot and actually pulling out parts and nomming on them. Be careful about that. Don't let your animals swallow any of this stuff. Try to set it in a hard to find place if you're going to get a cup of coffee or something like that.
Amy said she obtained one of the it was a unicorn shield around her. It was like a unicorn thing that goes around her Cyberbot.
Oh. And I don't know about that one. That's cool.
Yeah, it's fun. So she sent it home with one of the kids, and the same thing happened. The dog got a hold of it. Was like,
oh no! And it had all kind of teeth marks on it when it came back.
Now it's a broken unicorn shield. So.
Yeah. Yeah, I'll have to see what other offerings they got as far as dressing up your robot. That sounds pretty cool.
Well, I just sent I sent these two really gung-ho students on to a design for ours. So we're trying to make a tank right now.
Oh, cool. Have you seen our tank tread attachment for the?
Yes, and that actually is also getting pirated. I was looking at that going, got to be a way to make that.
Yeah.
Yeah.
If
We're
you,
buying two. I got two in my shopping cart, so we're gonna get those and put them on. And then I'm having this kid make the arm attachment, the thing that goes on the sides. Try to see how it all works. So let's
if
see.
you end up publishing it on Thingiverse or anything like that, send us a link.
No, I don't publish anything, so I know I'm bad, Mr. Yenner.
Well, if the students do, then.
Yeah, bad Mr. Yenner taking all these fun things and doing. No, I just wanted because I got a set of autistic children that are just, they go. So I figured, well, make a tank. And they're like, oh, and I said, hold on a second, make a tank on this thing. And I handed them a box. They had it built in 20 minutes and then the tank designed mostly. We'll get it printed out next week. Yeah, it's going to be pretty cool.
That is really neat.
But no tank treads on this one. It's just going to be a ball and wheels.
Okay. All righty. So quickly, I guess then, see here. So.
Okay, so Andy, I have a question.
Yes. Is that Smokey?
I got everything. Yeah, I got everything built, but I haven't got it tested yet because I have a software, a program issue, and I can't figure it out why it's giving me this error.
So Smokey, can we try something real quick?
Yeah.
Can you look at my screen?
Mhm.
All right. So what we have here is the, see if I can zoom in on this today. Okay. There we go. I might have overdone it on the Zoom here. Okay. So we all downloaded the robotics, the Shieldbot code.
Mm-hmm.
And so what I would like you to do is try opening it from here. So what program is it that you were trying to?
The IR test.
Okay, so that's going to be chapter 7.
Uh-huh.
And then, hey, for speed, I wish I had thought of this earlier. It uses LEDs too, but if you don't have the LEDs plugged in, it's no big deal. So test both IR and indicators. You can just open that one up, and that way it's pre-written. And I've heard from a number of teachers that when their students were really stuck, it's opening on another screen, and when it's done opening, I'll drag it up. But basically, when students are really stuck, the teacher will use the pre-written code, have the students bring up their bot, and then that way they can essentially figure out whether there's an issue with the code or their circuit, assuming that there was not a runtime error. So the thing to do, Smokey, is to, if you have an issue with the code you're hand entering, open the pre-written code and see that it works. And then you can even set it side by side with your existing project and try to figure out maybe what went wrong. For example, maybe this IR detect function was on another page and maybe you missed it. So that's an example of something that can be a coding error. And again, it's going to happen to us. It's going to happen to the students. It basically happens to everybody. And it's part of the troubleshooting process of, and it's basically something that everybody has to do, goes into the technical world, whether they're writing, whether
Right.
it's web page programming or, robotics or physics, or, there's always some gotcha. And that always has to be something that you either brain through and find it, or do a hypothesis and run a test to see if the problem is what you really think it is. And all of those things happen in the book. So to the best extent that I could, in the book, what we try to do is kind of best engineering practices, and always test one thing at a time, one subsystem, one sensor at a time, test the motors individually, test them together, put the robot together, retest the motors, test the whiskers first, do any troubleshooting you need to do, then bring the servo motors to the party with the whiskers. So it's always that sequence of, build something, test it, make sure it's working, then try integrating it into the larger system. And that is essentially coming from best engineering practices. And so that's why the book always does it that way.
Another question.
Yeah.
Where I have the link you sent me to the code, but
Okay.
where can you find it if you lose like the email or whatever? Is it available on?
That's a really good
other
question.
people?
That is an excellent question. I'm on my way to a web browser here. Okay, so basically, if you go to, I think it should be in two spots. I'm going to go to learn.parallax.com to the student tutorials first. Okay, and Arduino Shieldbot. So this is the web version of the textbook on learn.parallax.com. And notice that it says, hey, you can use the printed text. And you can buy it through this link, or you can download it as a free PDF here. So that is this textbook that we're in. So it's right there on the front page of the web book. Now it also has download the entire Shieldbot Arduino code from this page. And so you can follow this to get to the code download. And then there's the download button, and you'll have your zip. Just make sure to unzip it. The other way to do it, I believe, is if you go to the Educator's resources and then Shieldbot Educator's resources. Okay, so I guess, I'm sorry. Oh, did somebody see it?
I think it was in the textbook and code. I think that's where I got it from.
Okay. Let's see here. Textbook and code, textbook and code. Oh, here we go. Okay, so this is the textbook page.
Okay, yeah.
And then if you go to resources and downloads here, yeah, there's the tutorial code.
And there's the shield or
the book.
The book.
I believe. I don't know why it's zipped, but and then also look, here's the web tutorials, a generic code bender link. Make sure to email Parallax if you have a Chromebook class and need to use code bender for it, because we have licenses for you if you're using Shieldbots. So that your whole class, because if everybody tries to use the license that I'm using for this class, then we'll run out of our allotment of licenses, and somebody will end up not being able to teach their class one day. So make sure to get your CodeBender license from us, not through this link, but just by emailing education@parallax.com. I will add that to this next email after we're done with today. Somebody was about to say something.
No, I said I like the web tutorial. I set my Canvas modules up, linking everything to those.
Yeah, I like the web tutorial too. One thing is it's nice because unlike a printed textbook, you can just update it. The one thing about the web tutorials that I don't entirely like is the resolution of the images. So with the PDF, I was able to zoom in way more than, say, let's see here.
Does anyone have like a way, the students that I have doing some stuff right now it's hard for them to have the screen open, they say, and look at the book online
Mhm.
and then code. It's harder for them. I ended up pulling up like an extra computer next to somebody so they could do it. But is there any other, I mean, other than the book?
Well, there's their phone, there's a tablet. If personally, even when I have, say, a 1280 by 720 screen, like on a cheap laptop, I'm still going to mostly do it like this. Need to get something else. Okay, so if this is my code bender, so even on a cheap laptop with a low res screen, I'm still going to be tiling one on one side and one on the other. Now, sometimes I might actually do it a little bit more like this, where they overlap a little bit. If I really need something to be wide, I might go back and forth like that. But having them tiled is the best first suggestion I've got for anybody. And then if that doesn't work out, when you're, say, copying your code over, overlapping is the next best. But yeah, like a separate tablet or having it open on a phone, any of those things is definitely fine too. So I guess that the one place where this doesn't work so well is those older 4x3 monitors that are really low res. Those would be difficult to do this on. So that's all I can think of. Does anybody else have any suggestions for students when they're using a tutorial next to an editor?
I just put a note out there. If you have some old spare monitors, that's a pretty easy way to get things going. Just, if you got, even the junk bin is a pretty useful place at times to store stuff off if they're using laptops.
Yeah, okay. Yeah, that is a good idea.
My kids all had stated that they were just tired of digital, so everybody went to printed books. But I went and made blown up versions of these things, so they were actually full size from the PDF, and I just had the guy print up worksheets. That way they were smaller chunks, less to do. We went through and did it by hand. They can make notes, they can flip back and forth, and so far so good. But that's been the feedback. They just being able to see the stuff dingling around with the robot and then having to flip and toggle back and forth. And they are on much smaller laptops or Chromebooks. It's been kind of a challenge.
Mike, I'm glad you mentioned that because actually when I travel and teach this class in person, I print out things like this in color fitting on a full 8.5 by 11 page from the PDF. Now, this is one point where please, all points bulletin, use the PDF when you're capturing images, not the web tutorial, because hopefully you can see that this is a little bit grainy because it's we're trying to limit the resolution of the image for the sake of a web page. Whereas if you're over here on the PDF, it should be crystal clear. Oopsie. So this I don't know why it's jumping over like that. This should be much clearer in comparison. Does that come through over Zoom? Can you see that there's, okay. Yeah. Yep. So yeah, I have a list of pages, and then the worksheet concept is great. If you can take some of the assessment material and just stick it on a worksheet or even freestyle and, write your own questions based on what you know, that's great. Basically a worksheet that has, say, the circuit and the code, and then some questions that lead them into a deeper understanding. In a lot of situations, that's way better than a book, especially for younger grades. Okay. Let's see here. So going back to the test code, if I open up test both distances, which is in chapter 8. Let's see, chapter 8. Display both distances. And I need to try to get my video so that it overlaps. So maybe display both distances can go to desktop 4. All right, so if we run this now, maximize this, and then I'll figure out what to do with this in a minute, but let's just run it and then get the serial monitor running. Sorry, I realize that's looking a little dark today. Hopefully it won't matter too much. So here is, okay, does everybody see that I got an error here? It says error opening the serial port. COM10 is busy. That is probably because I have another terminal open. So what I'm going to do is just close any other Arduino editor instances I have open. Okay, we'll try again. Okay, it looks like it's working this time. It's done uploading. So that's a small message right down here. And so now I can go ahead and start up the, okay, so the distance is 5. And I do want to correct the expectation that's coming from the book. The book makes it look kind of uniform. My hand is coming closer, 4, 3, 2. Okay, I need to move the bot back to put the, hopefully if I put just the very front of the bot on one side of the, okay, so is that visible to everyone? Okay, so the distance detection, hopefully, okay, another way to do it would be to raise the camera. Also get extra serial cables out of the way. Let's try raising the camera here. Okay, so now, does my hand appear in time? Well, basically, all right, so here we have my hand at the very edge of the camera, and we're getting 5s and 4s. And as I move my hand, say about 3 inches towards the robot, well, maybe 4 inches, which is pretty good actually. So really the detection range is, say, starting at 10 inches out and going from roughly 10 inches to roughly 14 inches. And so I just wanted to kind of call that out for everybody to make it clear, because there's kind of an expectation from one of the drawings that one of the illustrations that I'll show you in a bit that that isn't, you know, that it's kind of a uniform thing, which it is for the Cyberbot and for the Activity Bot, because they are able to use a different approach to that distance detection. But for the Bobot and the BOE Shieldbot, they have to use an approach that essentially restricts you to a shorter range of detection, but it's certainly good enough for following. And let's see how that works. Shieldbot code, chapter 8, following Shieldbot. And so if any of you have not yet tried this, make sure to try it, get it to work, because it's a very, very worthwhile kind of end of the book activity. And that is the following Shieldbot. I'll go ahead and load that one. And let's see how we do here. Basically, I left the 3-position switch on 1, so it's not starting yet. Oh gosh, mine's not moving at all. Oh, here we go. See how it chased my hand off the side of the screen? And now I'm pushing it back because the force is strong in me. So, so this is a really good one, and it even turns. If you face your hand a different direction, you can lead it around and it'll turn to follow you. Mine's getting dragged around a little bit by its cable, and it's kind of a slippery surface that it's on. But hopefully that's a good enough demo to see kind of fun you can have with it. All right, so I definitely recommend getting that one going. That's a good one to get student interest, PTA interest, and any other.
Andy, what was the name of that sketch?
Oh, let's see here. Following Shieldbot in chapter 8.
Sounds good. Thank you.
You're welcome. And so first, make sure to run display both distances in chapter 8, and make sure that they both, I only did one of the sensors, but you want to do both of the sensors and make sure that one isn't way more farsighted than the other. Usually that's caused by having not the same resistors on the LEDs, on the LED flashlight. So you have a brighter LED flashlight on one side than the other. So test that out, and then you can do that sketch.
Does the angle of that also matter? Like,
oh, good question. Yes, it can very much so. And in fact, if you've got the same resistors, that is typically what I do, is I adjust the far-sighted one out a little bit, or the near-sighted one more forward a little bit. These are just a little bit too far outward. I wouldn't bring them both straight ahead, but I'd have them at a very shallow angle outward from each other. And then also mostly level to the ground.
Is there a difference that you're seeing in the sensor itself, or is it purely tolerances and resistors? So if we were to use a higher percentage resistor, would it be better?
Some of it may be that the filter inside because the infrared has to be flashed on and off at 38 kilohertz, 38,000 times a second. And so some of it may be that the filter is more sensitive at the exact frequency we're using for one and not the other, because the filter curve changes just a little bit. There may even be some crosstalk here, like you might find an improvement if you did individual wires from 5 volts to each receiver and from ground to each receiver. If you went straight as opposed to daisy chaining like is happening here, that can have some effect too, because there is a little bit that might be coming in on the ground of the second receiver that makes it more nearsighted. Tolerances was something you asked about. Yes, could be. Not so much on the infrared, not so much on the resistor, because it's really a 5% resistor. So yeah, it could be up to 5% off, but it's going to be pretty close. Likewise with LEDs, their brightness is fairly uniform, I want to say. But maybe electrically, there's more brightness variation than the eye can notice. So yeah, there's a lot going on. And so that final tweak of turning the nearsighted one or the far-sighted one forward and the nearsighted one outward, just to even them up is definitely going to help. All right. Let's see, do we have any other questions? I lost my slideshow. Let's see here.
I have one silly question really quick, if that's okay.
Of course it is.
So in the book, it shows the whole hold a phone camera, or digital camera over like a remote, and you see the glowing light.
Yes.
Does that actually work for you on this robot thing with like your cell phone?
Okay, so let's try this. So my cell phone, yes.
Okay.
Now I'm gonna try. I'll try it on. Okay, so press and hold. Now that could be dead batteries too, because I just yanked this out of my my tool chest.
What kind of phone do you have, Jess?
I'm sorry?
What kind of phone do you have?
Samsung S, oh Jesus, whatever the second newest one is, I don't remember.
Yeah, because it really varies from one phone to the next, whether or not they have an optical infrared filter in them.
Oh, that's what I was wondering, if it was like an age thing. So that's actually a really good point. Thank you.
Yeah, so finding a camera that sees it can be a challenge, and I think the newer stuff. Yeah. Oh, there we go.
Oh.
I got a little. I mean, it's really quite bright on my phone. It'll be interesting to see if we can daisy chain my phone camera to the regular camera. Okay, is this gonna work? Still lining it up. Oh, that's too weird. Yeah, you can still just barely see it, huh? Let's see, how about if we come closer? It's kind of interesting. It gets bright and then dim again.
Yeah.
Yeah, so it truly works when it works.
So that's fair.
So it's worth a try. Just see if you can find a camera or document cam that it shows up pretty well on. Incidentally, these guys will show up much less because the amount of time they spend sending out their infrared signal is kind of minute by comparison. So even though right now this is busy sending out its signals, we can't really see that. It's not showing.
Okay. Thank
So,
you.
You're welcome. Yeah, thanks for asking. That's an excellent question. This is all really good information, helping arm everybody to teach their classes.
I have a question about the code that so that we're using for this one, and then the code that's for some of the others.
Okay.
The Bobots and things like that. So
Okay.
the Shieldbot uses Arduino, which is its own language.
Yeah, it's basically C++ inside a wrapper. So all the syntax that you're using it is pieces of C++, because what's happening with the Arduino under the hood is it's using formerly Atmels, now microchips. I got that right this time. API, and that is a C++ language. If you're programming the microcontroller on the Arduino directly, it's C++. And so what the Arduino does is it uses kind of a lot of the what's provided in C++, but it takes it and it simplifies it so that all you have to do is enter stuff that you want at the beginning here and stuff that you want to automatically repeat down below. And but when you do so, you're using C++ syntax.
Okay, and then, well, and the reason is because I've been using just recently the activity bot with some students, and
Okay.
one student in particular who's done a lot of coding is unhappy with the, he doesn't like the block coding.
Oh, he doesn't like the Blockly prop
He doesn't
coding?
like yeah, he, you know, and a couple, I mean, and also since I'm unfamiliar with either one, you know, I'm having to learn it all at the same time. But
Yeah.
he was asking about, he saw me on the Shield and was like, what are you doing? Because I want to, that's what I want to do. Right.
Oh.
So I, you know, and I did say to him, well, there's the C code for the Shield, right?
Mhm.
Because you can, you don't, oh no, I'm sorry. The activity bot has some C code. Is that
Yes.
like, is that like basically the Arduino then and the C++?
Okay, so C++ is a superset of C. So first came C, then came C++. And although architecturally they're not derived, there's C#, there's even JavaScript is very, very much, the syntax comes from C++, even though architecturally under the hood, it's completely different. So like anytime you're clicking a button on a web page, JavaScript is what's under the hood, making it do stuff. So I'm starting up a project here. And so basically this is the activity bot. And so I might let's get the servo started. And then I might tell it to go some speed. Okay.
So
And
this
now-
type of language is not available for, like, this would be a good starter language for someone.
yes.
That's not available for something like the Shieldbot.
Well, I think that you could, I think that somebody probably could port, there probably is a block language for the Arduino. And so you might be able to, we don't have currently anything published, but it might be possible to program the Shieldbot. What I wanted to show here is that I just clicked code. Okay, so I was in blocks.
Oh, okay.
And I just clicked code. And so this is the C, and that's standard C code that got generated as a result. And so it's a little bit simpler in most syntax than the Arduino C is, but we leave the onus of having a loop to the programmer. So if they're adding a loop, they will have to take the block code and then switch over to C language. Now, you're really experienced student. You might want to send him to the Propeller C tutorials, because if he has an activity bot and he wants to program in C, basically the Propeller C tutorials, as long as he has like something that's not a Chromebook, if he's got a Mac or any Windows machine, he can. So this is what the C language in for the Propeller looks like. And it's kind of similar to the Arduino. Instead of loop, you just add while one. And so if you want to do stuff repeatedly, you can do it here. I think this is a good topic of discussion because C and C++ are very closely related. And so, you know, you can say, you can actually paste in what Blockly, I just pasted in what Blockly generated. See?
Andy,
Yeah.
in Arduino, so in embedded electronics, every microprocessor has to have a main function. In Arduino, that main function is just hidden from the user. If you can drill down far enough into the directory system, you can look at the main, and there's just one single call to setup. The while one is there, and there's the reason they separate it from you is Arduino is doing some stuff behind the scenes to service your serial port, and so that runs once every loop, and that's happening behind the scenes for you.
That's interesting. I didn't know about something with the serial port. That's I actually worked on a project to make what you see here behave exactly like the Arduino. And so I'm very familiar with that call to loop that's inside main. And the other parts, but I don't remember anything about the serial happening every time through the loop. But I also haven't been quite so deep into the, are you one of the teachers that was teaching assembly language with the Arduino? Remember there's at least one teacher teaching assembler here, and then there's another.
That's me.
Okay, yeah, and so so thanks for that, and yeah, so but from the user standpoint, the Arduino language is basically C syntax inside, you know, all of this here is standard C for using libraries. Arduino gives you libraries, and each one of these there's a delay function inside the Arduino library. Well, inside the propeller library, it's the pause function. So in the propeller, simple tools is kind of like the Arduino library. And so you can say pause 1000, and it has the same effect as delay 1000 right there. So the difference is that this is C++. So servo left dot attach is a class method call, whereas servo 360 underscore connect is the equivalent, and it's just a function call like everything else. There isn't any this dot that, with the exception of some data management stuff in C language. So that's one of the differences. That's one of the places where this standard C is a little bit lower level than the C++ using that dot operator. Hope that helps bring about a little bit of understanding of the similarities, and also for whoever said they had an activity bot and Blockly, and the student wants to program in C, he can program in using multicore in C. And so if you were to go to learn.parallax.com, so when you follow the activity bot link, if you follow it in grades 5 to 8, you'll get to Blockly prop. If you follow it in grades 9+, it's the activity bot with C tutorials. So they do still offer Blockly prop, but here is the activity bot with C. And one of the opportunities your student will have with the activity bot is he can actually do tutorials on multicore programming, which is kind of a cool thing. That's not to say that he shouldn't do the activity bot. he can, there's all kinds of interrupt things going on under the hood, so that when you say, set some kind of servo speed, it's still a set it and forget it process, even though the processor stays busy with making it go. Your code, you just do it once and then assume that the servo keeps running. So I hope that has been helpful, just in terms of taking on a few tips, because especially if you've got a student that really likes. I'm sorry?
Where or what is the multicore? Because I think what you pulled up, I didn't see it. I didn't see the name.
Oh, okay. This is the activity bot. So you said you're doing Blockly with the activity bot, is that right?
That's correct.
Okay. So going to learn.parallax.com. And then we have activity bot here in grades 5 through 8 and grades 9+. If you follow activity bot in grades 9+, it gives you two options. It gives you C tutorials and Blockly prop. And so you can follow. So your students have been using the Blockly prop tutorials and programming graphically.
Well, today I told that one student to go to the C, actually.
Oh,
But-
cool. Okay.
But what is multicore? What does that mean? That's
Okay, so with multitasking, that's the way a single processor can appear to be doing a lot of things at once. For example, when your program is running, you can play a speaker tone at the same time that the robot is moving on the Arduino. Now, the speaker tone, the Arduino is busy, say, 3,000 times a second, toggling a pin high and low. Well, also 50 times a second, it has to go and send a signal to the servo to remind it how fast it has to turn. That's, and what it does is it uses little tiny slices of time to decide when it needs to do each of those activities. So that's why it can play a tone at the same time that it operates the motor. In multi-core, the propeller on the activity bot actually has 8 processors inside it. And so what you can do is you can write some code for up to 8 processors, each having them take care of some different process. A lot of that happens under the hood, just like the Arduino's multitasking happens under the hood. You can tell it start moving the motor, and you can tell it start playing the tone, and they do both simultaneously, but it's because of the fact that it's multitasking. It's, each little slice of time, it's checking to see if it needs to make one of those things happen, either the speaker tone or the motor signal. In a multi-core processor like the propeller, what you're doing here is you can still make a propeller single core do multitasking, but you can also just say, hey, one core, go off and just keep on watching this sensor and change a variable value when something of interest happens on the sensor. And then you can have another core that says, okay, do the very complex thing that makes the special servo motors on the activity bot able to, correct their direction, their speed, so that you can tell it to travel certain distances. And it's just one thing where you say travel a distance. With the Arduino, you have to say, we'll set a speed that we've experimentally figured out, and then set a delay time. So the propeller under the hood
Andrew,
happens
I put
to
a
be.
really nice article from Adafruit.
I'm sorry. Did you paste something into
put
chat?
A really nice article from Adafruit. Yes.
Yeah. Okay. So in addition to that, I will put in the Parallax multi-core article that talks about the difference between multitasking and multiprocessing.
Hey, Andy, question for you on that one. Have you found that over the years, your, students, clients, etc., prefer the multitasking versus the multi-core stuff? Are you finding one group happier than the others? Just curious on your feedback. Sorry.
It's yeah, no worries. It's just that's something that I've been paying attention to now for, I think, 10 years, more than 10 years. People tend to gravitate to one or the other, but there's more to it than just that. Sometimes I'll see students that say, well, I picked the Arduino because there's so many things pre-published on the web, so I can just go and cherry pick my little subsystems and then put them together into a project. Others say, oh, I tried to do what I just said that other student did, but I ran out of processing power, so I went up to the propeller. So that's one set of arguments, but there's really a lot more to it. There's language choices. Some teachers will want to teach C++. Some teachers will want to teach standard C. And for those teachers, some of the other benefits and drawbacks just kind of fall off the table. It's just they've already made their decision based on a language. Other teachers, they've been using, say, the Bobot for a long time, and then it's been a long-standing thing with the Bobot and the Shieldbot that you have to do some tuning to get it to go straight forward by slowing down one of the servos. And when they find out about the ActivityBot, that it has special servos that know their position in space, they just jump on that. So it really varies. It turns out to be much more than multiprocessing. That there's the language, be it Blockly Prop for the younger crowd. The microbit is now very popular, and for very good reason, because tell you what, I'm going to jump back to that. I have to get back to my slideshow here because I have some slides to support some of these topics. I don't know how I managed to lose my slideshow.
And sorry to interrupt, Andy, but I think we can see your thumbnails now, just so you know.
Oh, okay. There we go.
Covering stuff, so.
That's funny. Well, thanks for letting me know. Let's see, where is Drive? There we go. I really do not know how I managed to lose this. Sorry, folks. But here we are. What to do while this is loading? With Murphy's Law, as soon as I get started on whatever that other thing is, it'll finish loading.
Well, I will say that having just only been introduced to the two right now, at first I thought I liked the ActivityBot and the Blockly code, but since we've been doing the Shieldbot, I actually like this coding myself, and I'm having a hard time knowing where everything is in the block code, because you know what you're looking for, but then you don't know where to find it. Where it'd be much easier to just type it in.
Yeah, well, also try the C code that comes with the ActivityBot, and go ahead and hit me up with an email offline, and I can show you some cool things about that, even an extra textbook that might be of interest. But yeah, whichever one works for you. I think that either C or C++ are two very important languages. C++, and Python are the three biggest stepping stones I can think of into the professional world. Python's growing, but C and C++, JavaScript comes from that syntactically. And then C and C++ themselves are still very widely used. So whichever one you like, I'll be interested in your final opinions, because it sounds like you're still getting familiar with both of them. So we saw some examples of troubleshooting, and then I just have on the slide, my basic list of questions on a tech support call, or when I have teachers in a room taking the class, and it's also the same thing I'd recommend you do when you get students who get stuck on the infrared circuit. What if it turns out that your infrared receiver is bad? Like maybe it got damaged somehow, or broken, or stepped on, or whatever. Well, getting extra parts for your robot. This is from parallax.com, and all I did was put small robot in the search. I'd like to bring your attention to the small robot electronics pack and the small robot hardware refresher pack, because these have a lot of parts. So you can have a lot of different students have 1 or 2 screws or standoffs or something roll away, and you can replace it out of this one pack. And it's more economical than purchasing it individually. Likewise, $3 for an infrared receiver versus $13 for a kit that has 2 infrared receivers and everything else is another good deal. And then here's the continuous rotation servo, if you need to replace that. So these are just examples from searching for small robot at parallax.com. And addresses the issue of replacement parts. Some other things I wanted to show were, we looked at this briefly earlier, but it was under the context of playing it back faster. This is the same circuit that you all have right now on your Shieldbot. And all you have to do is get a universal remote and set it to control a Sony TV, and then run some code that's at learn.parallax.com. And then you'll be ready to go with a TV remote controlled version of your Shieldbot.
Can you also do that with that handheld remote that's in the Arduino kits?
I don't know what protocol the Arduino kit remote. If it's a universal remote that you're making control a particular TV, then yes, because you can set it to control. So these are the grippers that you can also mount. This is an ActivityBot video, but
they're cool, but mine got destroyed as soon as the kids started building it.
Okay, this is a new version. The hope is that it's a little bit more robust.
It was the actual install, the way that those 2 pieces that are towards the rear of it, I guess we'll call them the arms.
Uh-huh.
The way that they actually got fused onto the sub post underneath it, and I haven't pressed go on the replacement parts for it yet.
Okay.
But all those pieces got locked in and put together. But that thing's cool. I played with it a little bit.
Yeah, I believe that what I just showed you is our new generation gripper. How long ago did you get the gripper?
It came. Let's see. Ken sent it. Might have been around the middle part of the first semester. So.
Oh, like this year then?
Huh?
This school year?
Yeah. Huh.
Oh, that's probably the new gripper. Did you tell them about that?
I did. I mentioned it in one of our other trainings. But I had it in I had the pieces. I got them from the parts list, and I went online to go order them, and it was giving me some gruff, and I just haven't gone back to do anything with it yet.
Okay. Can you email me to follow up on that?
Sure.
So this is kind of cool. It's using an ultrasonic distance sensor on called the ping sensor on a rotating turret. That rotating turret is a standard servo that sets position, and so it's swinging the ultrasonic back and forth. And our editor and I made this just as one of the maker fairs back when that was still a thing was about to start. And we kind of had some fun with it. These are all kits, by the way. The last session, somebody asked about the Pixie Cam, and I looked right at the link and thought it was the our Color Pal sensor. But no, I grabbed our Pixie Cam camera.
Yeah, I started reading up on that last night. I got really interested and ordered one.
Oh, good. I think you'll really enjoy it.
Yeah, I think it's much different than the Color Pal, though.
Yeah, because it's basically using a camera and then some vision processing technology to find a color and figure out the center of the blob in the camera, and then give you the coordinates of its position and its size. And you can do quite a lot with those XY coordinates. I'm actually going to reopen that because if it'll let me. Hello, there we go.
Do both of these work with the Arduino Shield?
Yes.
Fantastic.
Yeah, so everything I'm showing you here was probably filmed with the Shieldbot. No, because the rotating turret is a Shieldbot and an Arduino application, but that was filmed with the Arduino. I think the rest of these were filmed with an ActivityBot, but they have published apps. You know, both robots have published apps for the same things. And so the blob's left-right position, that yellow blob, its left-right position, you get a range of values, and it's also its vertical position, you get a range of values, and that's how it can know to back up as you push the block toward the robot. Oh, there I am. I guess I was next in the playlist. The last one, sadly, I don't know how to make Zoom send sound, but although robots don't like it when you anthropomorphize them, we all seem to love to do it. And so, so what we did here was make the robot into a cat by giving it some cat ears and a speaker. And incidentally, this is that is an application here. Let me replay that. Okay, so the robot comes up to, or the ActivityBot in this case, but Arduino bot comes up to the other robot, meows for it to get out of the way. It doesn't get out of the way, so it hisses, and then it goes in a new direction. And the cat ears complete the picture. So those are some examples of additional parts that can be, like here, for example, is the servo turret and the ultrasonic sensor. And so these are examples of additional parts where we have published applications for them. Like here is for the Shieldbot, we've got our roaming with ping, we've got our TV remote, kitty cat bot. I didn't do
But how do you add that extra servo on? It just attaches to the front?
Yes, yeah. If you look at the front of the robot, you'll see some slots. And here, see if we got any
That's a special
close-ups.
component. You couldn't take any old servo and put it on there, could you?
Well, if you have a standard servo that rotates 180 degrees, it might need some tuning, but it should work. If it's a different brand, if it turns left to right as opposed to right to left, for example, you might have to, adjust the code a little bit. But let's see here, 330 or it's 325. All right, so let's see, where is Arduino? Here we go, Shieldbot. I just wanted to show you where I got this. It's right down here.
People also have a lot of brackets out there in the hardware section that some I found helpful. There's L brackets and strap brackets. So you can attach virtually anything onto the front of the robot. That's just 2 L brackets.
Yeah, actually, I think these are straight brackets that are going
Underneath. Oh, yeah,
yeah.
it is. Yeah, you're right.
Yeah, so they're going under the front mounting posts in this case. But yeah, we could have used L brackets instead. Yeah, I mean, double stick tape.
No,
Let's see.
Students like that.
Yeah, zip ties. There's a lot of different ways to attach stuff. This one though, there's also an L bracket that is essentially the bottom of the L is sitting on top of the servo, and then the vertical leg of the L is holding the ultrasonic sensor in place.
Yes, we decided that was too short, and so they're 3D printing a new bracket so it goes taller.
Thank you. I meant to say that. I thought, okay, got to remember the double stick tape, got to remember the zip ties, and yeah, 3D printing, definitely another option.
Yeah.
All right.
What was that stick thing?
Oh,
Yeah, what is that?
so my wife is our product and documentation manager. This is, and so she's the one who did the costume, so to speak, and so this is a skewer for putting some chicken on and then sticking it over the barbecue. It's a bamboo skewer.
Right.
And so she put that in a bracket and then a little piece of cloth with some foam inside to give us the hobo over the shoulder
so
bag.
It's just part of the prop.
Yes.
You mean
Yes.
skewers, AKA axles, and in general overall great maker STEM kit items?
It's yes, and this one was purchased in the supermarket cooking implements section.
Right, the cheeses.
Yeah, it's funny how one person's cooking stuff is another person's inventing stuff. All right, so we talked about the TV remote already. And again, learn.parallax.com, going to the Arduino. So these are the links to the books here, but down below is where those add-on instructions are. So here's the Pixie Cam at the far right. Wanted to make sure you guys know where to find those. So we've already had some questions and talked a fair bit about conversion, but I do remember there was one question where I said, hey, we've got a slide about this coming up. Let's hold off until then. And I'm drawing a blank as to what that question was. Can somebody refresh my memory?
I think the question was, can we convert it from Arduino Shieldbot to a microbit?
And yeah, that was, I'm glad you mentioned that, because that was a question I think from the previous time. I also had somebody hold off from this time, or maybe I just kind of wandered back and answered it already. I'm not sure. But so mechanically, these 3 robots are very similar. And so if, for example, you want to update from a Bobot robot to a Shieldbot, there's a kit for that, and it's got the board, the battery pack, a different battery pack, and that's about it. If you want to go from a Bobot or a Shieldbot to a Cyberbot, there's a different board and the same battery pack as the Arduino Shieldbot, but it is different from the Bobot. But aside from that, the chassis, the servos, the standoffs, everything's the same. And so you're basically just putting a different top on it and a different processor. And go Go
You
ahead.
said battery pack. And so yes, not yesterday, I'm sorry, Wednesday, you mentioned that you would show us some battery pack stuff and info on what we should purchase. Is that something you could still
Oh,
do?
thank you. Yeah, let's see here. Do I have that? You know what? I don't see that in the slides. Okay, good thing you mentioned it.
I'm
yeah.
struggling in the land of batteries very badly, so I really appreciate it.
Okay. We can blame it on Ed. I showed him batteries after you all left, and so it slipped my mind. That was on Wednesday, so I probably had it mentally checked off already. Okay, so let's just try rechargeable here in the search. Okay, and here we go. So it's the, these are the batteries, and this is the charger. And these things are awesome. They hold almost as much, not quite, but almost as much as a good Duracell battery, but you can recharge them over and over again. So I'll paste these two links into the chat.
Silly question for you, Andy. The battery pack in the Arduino says 1.5 volt and those say 1.2 volt.
Yeah, and so let's see here. I will, let's hold on to that question for me. It's
Okay,
1.5 versus 1.2. I just don't want to let another question drop out. Okay, chat. And I got to select everybody. Okay, so these are the batteries. And then this is the charger. All right, so we were talking about 1.5 versus 1.2 volts. And in the book, in chapter 2, as you are putting together your robot, there's a step. Connect the servo motors and batteries. So we were here on Monday. Let's see here. Function F9, function F8. There we go. I don't know why. I still have to get Adobe set up so that it doesn't take this away. Okay, so this is of interest. It's page 61 in the textbook. And so I'm seeing it say not to set the jumper to V in, but I don't completely agree with that. Basically, if you have rechargeable batteries, they're 1.2 volts. And this little sleeve right here that covers 3 pins between the servo ports is called it's a power selection jumper, or just a jumper. And it normally and by default covers the 5 volt pin and then the pin that takes the power to the servos. Yeah, right here actually. So this can be pulled up off these 2 pins and slid back down over V in and the center pin. V in is the unregulated battery voltage. So if you have 5 rechargeable batteries, you know what? That's what it is. The Arduino, yeah, 5 rechargeable batteries. That's going to be 1.2 times 5. Is that 7 volts? I believe it is. And so that's possibly just a little bit over the standard servos. I think the standard servo is set for 4 to 6 volts. So that is why, okay, now it's coming back to me. That is why they don't want, you to set this jumper to V in, regardless of whether you're using rechargeable or alkaline batteries. With the Arduino Shieldbot, which has servos that take 4 to 6 volts, you want to have this set to 5 volts because that's in the 4 to 6 range, whereas either alkaline or rechargeable batteries take you over that limit. So that's the answer there. But as far as running the bot, either one is great. There's I like the nickel metal hydride rechargeables personally, but for some reason I forget to put them in the charger, so I find myself using alkalines about half the time.
Can you just explain one more time? So if you do have rechargeable, you use the same setup that we have right now.
Yeah, either way, rechargeable or alkaline for the
I know, but you were describing whether to move this pin one way or another.
yeah, so
Didn't you
if
do
for
it
example,
like
you oh, go ahead.
Well, you know, the one that's X'd out, when would you do that? Like it's saying, don't do that.
Right.
And don't do that even if you have rechargeable. But when do you do it? I don't.
If you got, for example, feedback 360 servos that go on the activity bot, then you would move this to VN because they expect a higher supply.
Okay. Right.
As an example, I mean, it's basically there for power users. So another place where you might do it is if through experimentation you found that the servos didn't immediately burn up when you applied that extra power and you're not worried about voiding the warranty and you want to win a race, well, that's one step that can be taken.
Do you think there's ever going to be like a battery pack we could add, or like a lithium ion, like is going to last a little longer? So the problem I'm running into is I took over some guy who retired's class and he has 6-year-old rechargeable batteries, and obviously they go to kaputs in 5 minutes flat.
Yep.
So is that something that's reasonable? Could I remove the battery pack here and add a lithium ion thing? Like,
you can, let me see here. I think we discontinued ours because there were, a number of challenges to our rechargeable battery pack. Let's see if I search for Lion, let's see what happens.
I would recommend staying away from the lipos. The lithium iron are fine, and even if it's a higher voltage, I've not run into a problem. And Andy, we talked the other night about I do sailing with a boat, but I would stay away from the lipos. They have to be watched. You can't plug in a lipo in a room and leave it plugged in to charge. They have been known to explode.
Yeah, and to spontaneously combust. So,
we had over $150,000 worth of damage done to one of our buildings because somebody charged some lipos and walked away from some coffee.
Yeah, they don't.
oh my
do
God.
They don't
Don't
sell
do it.
bags. In fact, I think aren't they still on the Parallax site? They have the lipo safety bags.
yeah, okay, let's try that. Yeah, that was for our Elevate, quadcopter.
Is Lipo a brand? Is that just a brand?
No, lipo is lithium polymer.
Chemistry.
It's lithium polymer, and it's the lithium part of it. And Andy, I have one of your Elevate helicopters.
Uh-huh.
It was that same type of battery, but it wasn't a Parallax product that lit up. But it was exactly the same type of battery.
Wait, so Ed, you sound like you had an opinion on batteries. What are you using in your class right now?
I don't know if you can see this. This is one of the things I have used, okay? And this is rated at, they're relatively inexpensive. It's a Life battery, LIFE. I use these in it's a 1 meter sailboat. So imagine a yardstick. That's how big the boat is.
Okay.
And I can sail for a whole day on this one battery, and I'm driving steppers that are heavier. They're digital motors. They draw more power. Okay, so I have to be able to pull a sail in when there's a 20-mile-an-hour wind. But these are nice. I've thought about them, but again, you'd have to glue something together. If you look at the connectors here, they look like the standard ones for the servo. In fact, they are. But these are rather nice. But
Can you guys see Ed on the screen when he's showing you what these are?
I'm sorry,
No, that's fine. I should pin you for a minute here.
So Ed, how are you plugging this into your robot? Because that's not that barrel plug.
Here's where you're gonna have to do a little surgery, okay?
Oh, I'm
not
fine with that. This is great.
I'm not using these in the robot currently. In fact, that's why I'm looking at this solution here with the Tenergy, and the reason why is,
Yeah, before you do surgery,
yeah,
these Tenergies are great.
the one thing is, if you read about it, I know it just shows a picture here, but I went out to Tenergy's site. This thing actually monitors every battery charging. So it's not just a dumb charger where you plug it in for 10 hours or 8 hours or 6 hours, and then you wind up damaging the battery after a while because you're overcharging and the battery's overheating. I'm very tempted. Right now, Harbor Freight has been very good because I have a student whose father works there. So I've got a case of AA batteries. I mean, a big case. But once they're gone, I'm looking to do this. I think this may be the way to go.
Yeah, it's a fantastic system. As Ed said, this is a smart charger. It's analyzing each battery and its current consumption as it charges. Even if you turn the power off and back on, it'll decide whether to continue charging certain batteries or just leave them be because they're already charged. So the batteries can sit in the charger as long as you need. The only
I'm sorry, I didn't mean to cut in, but this is one thing this charger does. It will actually cycle the battery. So you're not just continuously topping the battery off, which is also a bad thing for batteries. I mean, that's one reason why laptop batteries don't last as long as they could.
Ed, is that a Lipo battery?
Which one?
The one you were just holding up?
This is a Life battery, LIFE. Okay. I mean, obviously you can't tell with me holding it here. This is very lightweight. Okay. In fact, if you look at this, it even has paint on the end because when you race, before you can race, they weigh everything on the boat, including your batteries. So, but these have lasted a long time. But if you let them discharge all the way, you can throw these away. You have to, you can never let the Life batteries, you can never let discharge all the way. The chemistry really goes. And I just repaired the batteries. Be careful with them because I just repaired one of those readers the school had. And I don't know if you people remember the exploding phones that Samsung had a few years ago. Well, thank God it's not a Kindle, it's the other device. Thank God the back was soft rubber. You'd have to see how thick this battery swelled. I mean, I think this is a safe proposition. I would.
Yeah, I mean, basically, I was the engineer who picked these out, and so yeah, I'm hoping that anybody that watches this YouTube video realizes that Ed is talking in his thumbnail about a battery that he has, whereas these batteries that are on the screen right now are what Parallax chose based on, you know, how good they are as simple batteries for robots, and their level of safety, their longevity. And basically just their, you know, the way the charger works and its safety factors. These are basically an awesome solution at a reasonable price. And so for your two-wheeled robots, I really think this is the best thing going.
So
And
what's
it
your,
requires no
lifespan?
surgery. I'd have to look up the charge cycles because I do not remember off the top of my head. I'm looking to see if it says something here.
No, that's fair. I'm looking at, because I mean, this is a class that for us runs every fall or every other fall or whatever. Am I okay to leave these uncharged for a semester and a summer? Are they going to work the next year? Am I buying these every year? It doesn't matter to me that much. It's one of those, like, I just want to realistically plan for a budget.
Yeah, I'm sure they'll last say at least 2 or 3 semesters. That much I'm very confident of. But if they're left a number of times sitting, I mean, you can charge them all the way up. The thing about nickel metal hydride batteries, which is what these are, is that they they do self-discharge. These self-discharge more slowly because they have a new special design compared to the original nickel metal hydrides, which, you know, you'd never use those in, say, smoke alarms because they just self-discharge faster than the smoke alarm drinks current from them. So Ed mentioned that they cycle, so leaving them in the charger is probably a safe bet. But even if you leave them out, I can't really see them self-destructing, unlike the life battery that Ed mentioned, which
Andy, there's a lot of information on the Tenergy site. I mean, they're talking about a really, really slow discharge. So you can leave this battery, you know, charge it up, leave it, and they say for a long time. They had some really good data on the Tenergy site. I mean, if you really want to get into it, the information is out there. I went out there to look because, you know, I want to make sure. I haven't had a good experience in the past with using rechargeable batteries, especially NiCads, and, you know, just being abused. But no, there's some really, this is the way I would go. I wouldn't mess around with the other thing I showed you. I mean, it will work, but you're on your own. Well, no.
Yeah.
Fantastic. I really thank you so much for answering all these questions, you guys.
Well, this is what this day is mostly set aside for. I mean, you guys have done the heavy lifting already, and it's mainly implementation stuff that we want to talk about today. So this is all exactly, you know, within the plan for the day. Sorry, I'm looking for the chat window.
Just one last thing. I mean, the LiPo, I had converted a car, an RC car that we picked up at Toys R Us, and then converted it, put a Raspberry Pi on it. And it obviously, Raspberry eats up a lot more energy than the Arduino. We used 2 18650 batteries, the LiPo batteries on it, and it would eat those up in a half an hour.
Yeah, yeah, that's laptop batteries are the thing there. Those battery backups where you can completely recharge your phone from them also work kind of nicely in Raspberry Pi robots.
Yeah, but you get into that weight to torque ratio. Basically, you put enough batteries on it, the car ain't going to go anywhere.
Yeah, true. Okay, and so yeah, the activity bot is a different thing because it has special servos that are faster and they know where they are in space and they can report it, but it also requires more processing. Even the Raspberry Pi has challenges with it. If you're trying to run feedback 360 servos, I'd recommend basically having the Raspberry Pi tell the propeller what to do with the servos, because the propeller has a library that because it's multi-core, it can have an entire core that's busy just doing everything perfectly and exactly the way these servos need them in order to get the expected results, whereas other processors are not quite as good. The Cyberbot has a propeller underneath the white breadboard here. It's facing the chassis under here. Cool thing about the Cyberbot, it has built-in radio, so you can network your robots. It has a built-in compass, so you can know what direction you're going. It's programmed in Python, which is one of the new up-and-coming scripting languages, and kind of a popular employability request. It's also got built-in light sensor, built-in accelerometer. You can have another microbit that you can tilt, and then it sends radio signals to this microbit on the robot to make it drive different directions. Just a really awesome system. So the Cyberbot is worth looking at, and I will be sending you links to this same class, but done with the ActivityBot 360 and done with the Cyberbot, so that you can look at those YouTube videos, even play them at 2x speed all the way through, if that's what you're so inclined to do. Just, so you can find out more about them if you want to. If you're happy where you are with your Shieldbot, I can understand that completely too. But just for the sake of, giving you as much information as possible about all of them, I want to put that at your disposal.
Can I ask you a question, Mandy?
Yep.
If you were to start a brand new, let's just say we've never touched robotics, like all of 20 of us or whatever, or 12, what's your favorite to work with and why?
What grade level?
Insert your favorite grade level here.
Well, it's just really a toss-up. My personal preference is towards the ActivityBot and the Cyberbot. The thing I like about the ActivityBot is just its abilities and its power. It can do more robotic things, but the different built-in things on the Cyberbot's microbit, like the built-in radio, that's also just huge. So regardless of whether it's the multi-core and the ability to really do things well as a microcontroller, or whether it's a system on a chip that's basically a microcontroller with a whole bunch of built-in stuff, as in a Bluetooth radio, and then additional stuff like that tilt sensor, the compass, the temperature sensor, the light sensor, all that stuff built in makes it a little cell phone, or a little cell phone microcosm. So, man, between these two, they're definitely my favorites. And then for me personally, the Shieldbot comes in second place with the Bobot. But the argument, another reason that I'm in that camp is simply because I work at Parallax and we've made the propeller. I think if I were a teacher on the other side of the country, I would probably be looking on the web and I'd see, the Arduino has so much stuff published for it. And so that's a tremendous argument towards the Arduino. So really these three are all great. The basic stamp is great, but it's older. There are still teachers that like to use it because they like the fact that you actually have to code in the part where you're reminding the servo what it's supposed to be doing at 50 times a second. So that's actually visible in the basic stamp code. And for some teachers who want to teach lower level, but not necessarily assembly, they find that to be attractive. Some teachers also still like basic. So yeah, that's a toughie. Yeah, I do personally lean towards these two, but I'm kind of disregarding the argument of how much published material there is out for the Arduino. There's basically more than you could possibly utilize.
Andy, I have a related question, may I?
Yes, certainly. Certainly.
I found you through the Carnegie Mellon CS STEM modules. Does your book, does that correlate with the stuff that they have? Or is that related in any way?
Yeah, because aren't they using the Shieldbot?
They wanted me to buy it, and then I went and looked on Parallax to see if you were selling it cheaper, and I found this, and this has been awesome. But they had other trainings, and they have all these resources.
That's something I completely forgot when talking about the Arduino. Thanks for bringing that up, because yeah, Carnegie Mellon has a curriculum around this. They take some of it from the existing textbook, but they also have, is it called Robot C? Is that right? I don't remember the name of their special.
It used to be Robot C. It may still be.
Okay. So they have a special programming language that has a number of built-in learning experiences that are potentially important. So that actually now that you've reminded me of that, and sorry I didn't mention it earlier, that kind of puts the Shieldbot at the same level with these guys, and it's really going to be, you know, potato, half a dozen of this, 6 of the other. It will come down to personal preference and your goals for your class. And the important thing is just that you are aware of their relative merits and drawbacks. How was that?
Good. Do you know, does their training, does it offer anything that you haven't given us here today? Other than I asked about the Pixie camera, they had a little thing about it, but I can figure it out on my own. But
I'm sorry, I don't know the answer to that, actually. Has anybody been to their trainings?
Which class, which one are we talking about?
The Carnegie Mellon that uses the Shieldbot.
I've done the everything up to and touching the pieces where you start to get into the coding.
Okay. Yeah, because I believe that the Robot C, I did look at it at a trade show, and it has some very good features. And it has, I believe, a block language that actually generates the C code side by side with the blocks, which is another desirable thing. I see one that took Lego and CMU, and there is, and somebody's wife uses the Cyberbot in middle school and loves it. That's awesome.
My wife is the one who kind of flipped me into this whole bit, but several years ago we went to a thing where I did the Cyberbot training first in Colorado, and then I went to the second or third day, whatever one it was. I went to the Shieldbot, and I liked the Shieldbot because it not knowing anything about these robots, and I liked it was because it did have a lot paralleling on what you said. They had there's just a ton of stuff to do with the Arduino. And then when I actually became a teacher, they supplied me with 45 of those things. So it was a natural bleed over. But as Amy starts to use the Cyberbot, she's all over that thing. And you want a commercial with somebody who's a user? She's sitting right next to me over here. She'll give you everything you need to know about why they're the coolest ones.
and they really are awesome.
Yeah, and they're more powerful. I mean, I think the processor is better than the Arduino, and there's a lot more things going on the Cyberbot.
Yeah, the Nordic system on a chip is incredible, and again, this also has a propeller in it, and actually the robotic tasks are being just sent as commands from the microbit to the propeller, and then the propeller's doing that, which frees up the microbit to do other cool things. And there's also just a site called Make It Code It that's really cool. This will all be in the YouTube videos. Since I'm sending you the equivalent of this class on YouTube for both of these robots, you can kind of look at those at your leisure, and that may answer some more of your questions as you kind of see a little bit more into how each one is used.
Those advanced servos, can those be used with that Cyberbot or no?
Yes, they can.
But they cannot be used with the Arduino.
That's correct. The Arduino does not have multiprocessing, it has multitasking. And so those 50 times a second reminders come off of the perfect 50 times a second slot. They come a little before or after, and that causes the servo to kind of spaz.
So if you really, really were going that route, you would recommend the Cyberbot or the 360.
Yeah, I mean, if you really want to get the most out of the 360 servos, then the ActivityBot. But if you want to have the option of putting 360 servos on a robot, the Cyberbot's a good one too, because it has a propeller on it, and the propeller is capable of doing what it needs to with those motors.
Okay. Do they touch on that in that class that you're going to send us?
I believe so.
Okay.
Yes. Almost positive. I'm going to pick there were 3 or 4 of those classes done online, so I'm going to try to pick the best one. I won't necessarily know if they said that or not, but I believe most of the time they do. educator resources. Well, we did talk about this on Monday that, and then we sent you the parallax.com on Wednesday. We sent you the learn.parallax.com sign up. So once you sign up and you go to the educator resources and scroll to the bottom, you'll see this, you need to be logged in. And you click it and you log in with the login that we sent you. And then you'll have a live link to the hidden materials that are assessment materials for you to set up for your students as you see fit.
Sorry, Andy, you froze on my end and it just came back. What, can you just back that link thing up again? I'm sorry.
Okay, so this was just at learn.parallax.com. And what you do is you go to educators. That's the tab up here. And then for the Shieldbot right there. And so all of these resources, whether it's the standards matrix, the strategy guides, these are all public because they don't have any solved questions, exercises, and projects. So what you have to do is you have to follow the login here. And when you follow that login and log yourself into learn.parallax.com, what looks like this, which I just showed you on the page, ends up changing so that it looks like this. And then when you follow this link, what you'll see is a whole list of downloads. And I have a big warning there because the solutions are inside those downloads. So don't like print out the whole thing and give it to your students because they'll have they'll end up with the solutions. And besides, the textbook has a set of solved questions and exercises and projects that the students can practice from. And so these can be deployed, downloaded and deployed by you for the sake of assessment. In addition to that, cyber.org, which you might have noticed we've mentioned it numerous times, and that is the cyber and cyberbot, as cyber.org approached us and said, hey, how about if we do a microbit version of the Arduino bot, and we'll call that the cyberbot, and maybe even delve into some cybersecurity with it, which there are tutorials for that as well. So when you come here, if you're not already plugged into cyber.org, they have an entire other set of free curriculum. And it's vast. There is just a ton of stuff for the Arduino, for the cyberbot. I think they still have stuff paid on there for the old Bobot as well. And but they also go to a variety of other topics. As you can see, they've got 3D printing, A+, math, and engineering math. So they have a ton of useful curriculum. And here is an example where I went into cyber literacy, and that is where you will see our Arduino. So here's the old Bobot, here's the Arduino, and then here's the cyberbot, and they're basically the same lessons. And then, whichever robot you've got, you just want to follow into one of those curriculum tracks. And so that's a free, if you're not already signed up with cyber.org, when you sign up, the requirement is that you are a United States teacher. And because it's a Defense Department funded workforce development and cybersecurity effort. And so they're doing it for teachers in the US only. And so then you can have a complete second set of curricula. You can use all of it or all of Parallax's, or mix and match, whatever works the best for you. I did want to touch briefly on a few engineering topics. I know we're 5 minutes past, but I just wanted to highlight a few things. I think I'll jump through here and try to point out some spots where engineering topics come up. One is the filter inside the distance sensing system, where I showed you how the robot can follow my hand. Well, it's because inside the infrared receiver, it has a filter that is attuned to infrared that's flashing on and off at 38 kilohertz. That's 38,000 times a second. Well, if you flash at 39 kilohertz, it's only 80% as sensitive. If you go up to 40 kilohertz, it's only half as sensitive. And, by 41, you're down to 30%. Well, what that does in terms of distance detection, and this is where I said the graphic is kind of misleading. Again, you go out about 10 inches and then you have about 4 inches of distance detection. It's not this big, beautiful thing, unless you've got the ActivityBot or the CyberBot, in which case you really do get this because they have some extra goodies inside that make it possible. So what happens is, when you're using the best frequency, 38 kilohertz, you can see an object as far as you possibly can. But when you use 39 kilohertz, suddenly, because of that filter inside the receiver, the whole thing becomes nearsighted, and you'd have to move the object closer to see it. And then you go up to 40, and the object would have to be even closer. And so what the code does is it says, okay, let's try it at the best frequency. I saw it. Let's try it at the next best frequency. I didn't see it. Or I saw it again. Okay. And then let's try it at the third and fourth and fifth. Gee, I did not see it 1, 2, 3 times. That must mean it's in zone 3. And you can actually go through this and do it for any of those scenarios. And it turns out that counting the number of times you don't see it will tell you what zone you're in. And that's how we got that number of 0 to 5, where 5 is out of range. This is, I noticed a number of PEs attending this class. And so I wanted to mention this is one engineering topic where we're talking about a practical application of frequency. Another thing in the following portion is that we use what's called a control system. The system is something that can change on you due to other factors, but you get a measurement out of it because you have the little infrared detector that tells you, oh, my distance is 4. Well, set point, and that's a control systems-esque word, is the desired distance. So we want our desired distance to be 2, but it's 4. That's too far away. By subtracting the measured from the desired, we get our error. That's another control systems term. And then in proportional control, where you just say, well, I'll just try to correct proportional to the error, it's a simple multiplier. And our constant of proportionality that we use in the code is 50. And so negative 50 times negative 2 for the left servo, I think it's the left servo, means basically output of 100. And that's full speed forward, which makes sense because the object's way too far away. So you want to go full speed forward. And what ends up happening is if you try different numbers for that measured distance and then run through these calculations, you will get different outputs. So that's another engineering topic. In the phototransistor realm, we have the wavelength, talking about infrared through visible light. And we also have some basic stuff like a phototransistor, which is a light intensity sensor. Basically, more light on the phototransistor causes it to conduct more current. Well, with more current, Ohm's law is a very fundamental thing. It's kind of like the electrical version of distance equals velocity times time. In the electrical world, it's voltage equals current times resistance. And so more current through this fixed resistance results in a higher voltage right here that you can measure. And so this is Ohm's law where it gets introduced. Other engineering topics, we have our multipliers and powers of 10. So micro is times 10 to the -6, nano is -9, and pico is -12. And we talk about how to use the special code on a capacitor, which is a small storage element, well, kind of like a tiny rechargeable battery. And we use those with light sensors and some extra math. We even introduce exponential decay as a topic, and also normalizing measurements so that you can say, you know, what's the ratio of my right sensor to the total, and you can actually use this right here. Basically, the right measurement over the sum of the right and left measurements minus 1/2 to figure out whether the shade is on the right. So here we have a shade that's approximately equal. But here there's 5 digits in this shade measurement and only 4 digits in this shade measurement. So we know that the shade over here is really high, and we have an almost positive 0.5 value. Now, then we put the shade on the other side and we get almost a negative 0.5 value. And then we're back to almost equal again. And what this does is it makes it possible to make some shady decisions, which is one of our favorite puns in the office, where you can basically say, oh, if there's more shade over one of the sensors, let's slow down the wheel on the other side. And the net effect is that it follows a flashlight beam. Or you can swap the effect of the shade and have it have it look for shade instead of lightness. And so these are the different ways you can contact us. And that is the end of the slideshow. Oh, I'd like to emphasize the Educator hotline is very important, especially if you're in class, your students are waiting for you. You might actually be able to call that to get some help. Also call it if you have more questions like the ones you've been presenting to me about trying to decide between the Cyberbot and the Activity Bot and the Shieldbot. If you're still not sure after, you know, looking at the various presentations, maybe even further talks with me, you can try the Educator hotline, because Ken, who organizes this whole thing, he's usually the guy who picks up, and he knows a lot about all the systems too, and can definitely help you out. So, and then learn at parallax.com. I should actually add here education at parallax.com. Education at parallax.com is really important, because if you use that email, I'll see it. Our product and documentation manager will see it. Ken Gracie, who mans the Educator's hotline, will see it. And basically, whoever is most confident on whatever you're asking is the one who's going to pick up the email and respond. And then, of course, we've got social media and forums and et cetera. And that is the end of the slideshow. And I sure am glad you all came today and have been coming this week. The questions have been awesome. And I think we did pretty well as far as getting a couple of applications, you know, both the Whiskers and the infrared out of the way in a 6-hour class. That's quite good. So we can all hopefully be happy with what we're coming away with. And at this point, I think I'd just like to open it up to more questions and answers. And, you know, they always tell me to have a straw man question ready if nobody says anything, and I got nothing. We've pretty much talked about it all. So I guess, again, just to wrap it up, I will be sending out the YouTube recordings of this session, and you'll have YouTube recordings of the previous two in my emails before. I'll also send out ones of the Activity Bot and the Cyberbot, so you can see those as well. I have, I believe, 6 of you who have requested certificates for submitting to your district. You can still email me if you're somebody who needs a certificate as well. And we'll check your email address against the number of minutes attended. And then if it's in the neighborhood of the 6 hours, that's what we will put on the certificate. Let's see. Yep. Make sure to basically stay tuned. Our Facebook page is a good one for that. And you will probably get occasional emails announcing events. And you probably got one, and that's why you're here. So keep an eye on those as well. And I think that's about it. Thanks again for coming, everyone. And I'm going to go ahead and pause the recording, and then I'll stop it if nothing more comes up that needs to be on the recorded answers. Go to the final slide. Pause and then stop recording. So we are currently recording, and now if you are on YouTube watching this, thanks for watching. See, do you want to stop cloud?